Hey everybody, how you doing? It's CCNA Vicious here today with another weekly update on our tutorials for Cisco certification and training. This is going to be the fourth installment of that series. We're going to be finishing off the very last of the 4 labs you can get off of GNS3VAULT under the CCNA routing and switching section. Our first 3 videos covered OSPF and the 2 assessment labs. So today we're going to be doing the EIGRP lab here. Let's look at our goals. We're going to have this list of goals to go through, and we have those kind of screenshotted here to make it easier for us. We have Super PuTTY with a connection to all of our routers, and here's our network topology in GNS3. So yeah, today was a good day. I went and took my ICND2 test, which is the final one I needed to complete my CCNA certification, and just destroyed it. I got a 986 out of 1,000. So only missed maybe 2 questions on that test, and that was really great. So I'm happy about that. We'll do some celebrating later. And so we'll continue on with the CCNA videos for a while yet, and then eventually pick up to CCNP as I start studying that material. The very first thing I want to do on this video for you is go over the network topology. The more familiar you are with the topology, the easier to follow this video will be. Like the last 2 videos, we got the interface labels up here, so we can see serial 00, serial 20, fastethernet 10. That helps us know what interfaces we need to go into. In addition, we have our host names on all the routers, so Bond, Bates, oHara, those are up there. We have a frame relay network here, so these 3 routers are connected through frame relay, and we have network statements as well. This is going to be telling us that, for example, these 3 links are on the 192.168.134.x network, and here the .3, the .4, the .1, that would be the full IP address. So the IP address of, say, serial 00 on Bond would be 192.168.134.3. Now, in addition to that, all of these routers have a loopback 0 interface configured with a IP address. And there's a 1111, there's a 2222, 3333, 444, exactly going on like that for all the routers. Rather than overcrowd this topology by writing those up here, they're actually correspondent to the IP addresses you see here. So Bates is going to have the loopback 1111, Bond would have the loopback 3333, oHara would have 2222. And that's how you would be able to read those loopback interfaces, by looking at the topology. And we'll be using those pretty regularly throughout the tutorial so that we know we have connectivity to different routers. So EIGRP is really great. That's a Cisco proprietary routing protocol. I like it a lot, even though in my production environment at work we use OSPF. So I'm excited to do this tutorial. It has a few difficult pieces to it and a few easy pieces, and we'll try to run through them together. Let's go ahead and get started on our goals. We have IPv4 already configured on all of our interfaces, so there's no IP addressing to do here. And it's letting us know that each router has that loopback 0 interface, which I just told you about. So the very first thing we have to do is going to be configure EIGRP Autonomous System 1 on the frame relay network connecting Bates, Bond, and Corleone. So these 3 routers here connected through the frame relay switch, those are the ones we're going to be configuring first. Bates. Let's start with Bates. So I just, before I started up the video, I went ahead and put logging synchronous on all the routers. That way we don't get these system log messages interrupting what we type. That makes it easier to do things and easier for you to read. First thing I always like to do is show IP interface brief. I know we have our network topology up here, but this is the way I would do it without the topology, so I can see what interfaces and what IP addresses we have. And they want us to add the serial link here and the loopback to this statement. So we're going to go configure terminal router EIGRP Autonomous System 1 network, and I'm going to do serial first, so 192.168.134.1, and then we're also going to do the loopback. And I'm also going to do no auto summary. I always turn off auto summary when I'm messing with RIP or EIGRP. That's just a good practice, I feel, and it's also just my habit, so we're going to do that as well. So Bates is done. Let's move on to Bond. Do the same thing. Show IP interface brief. Of course, you have to spell it right. And we only have 2 connections on here, so it's easy. Okay, so you can see our first adjacency came up. As soon as we added the serial interface here from Bond, it connected over to Bates and that neighbor relationship formed. And now we'll move over to Corleone. I'm going to say that wrong so many times I can just tell. I didn't make the lab, so I didn't make the names. I actually considered changing it just so I could say it better, but I didn't. So serial interface, we need 00 is the one on this side, so configure terminal, router, EIGRP, Atomic System 1, network, and 192.168.134.4. And I'm sure you know, or if you don't know, I'll explain to you that when it comes to EIGRP, you can do the network statements like this, similar to how you do OSPF with the wildcard mask, or you can do it like you would with RIP, and you can say network 4.4.4.0, and that would be my statement. I don't have to add in the wildcard mask. Just remember that when you do it without the wildcard mask, that you're going to be stating the classful subnet mask as the default. And so just to prevent any mistakes and to have more control, I always do this. And of course, if I was doing multiple interfaces within the same network range, I could, do a larger range by changing up the wildcard bits. So that's how I do it. And no auto. And did we do no auto on Bond? I'm not sure. So better make sure. Okay, so that step is done. Autonomous System 1 is set up, and we should go ahead and check it. So let's go to Bates. Let's look at our routing table. We can see 1, 3, and 4. So 3 is Bond, 4 is I told you I'm going to say that wrong. Corleone, Jesus, that router. And Bates is directly connected, so I can see all of them. Let's ping them as well. Good, ping. Good. Now, it actually takes us to a problem next, troubleshooting. It says you'll notice that router Bond and that router do not see each other as loopback interfaces in the routing table, and you have to configure Bates to solve this. So let's go look at the routing table on Bond real quick. And I only see one, which is Bates, and then I see myself, and I'm not seeing Corleone. I'm just gonna not say it anymore. So we have it all set properly within EIGRP. The reason it's not working is because you'll probably run across this knowledge a few times as you're studying. When you have point-to-point connections over frame relay, you're good to go. But when you do multi-point connections like we have here, we're using one interface on Bates. And let's look at that again. Let's do a show IP interface brief. Alright, so the serial link 2.0, you'll see that we're not using the physical interface, we're using a sub interface here. And we don't have two of them. We don't have one for this router and one for Bond. We actually are using one interface for both. Now let's go look at the running configuration real quick as well, and look at that interface in our running config. You'll see that we're mapping both of the DLCs to both routers sharing an interface, and that's a multi-point interface. The problem is one of our loop prevention protections, which is split horizon, says I can never send a routing update out of the same interface that I received it on. So as Bond sends his link state advertisements and all those things to Bates, Bates is going to get them, but he is not allowed to send them back out, and so therefore the other router never gets it, and vice versa. So the only way to fix this is either use point-to-point instead of multi-point, which is what I would do personally in a production environment, or we have to do a full mesh, which means these two have to be connected together, and they're not because we're going through Bates. Or in this case, the last resort is to turn off the split horizon. So we're going to go into that interface. We'll go interface serial to 0.1 and no IP split horizon. So as soon as we take that off, if we go back to Bond, it should update fairly quickly. Let's look at that routing table again. And not yet. It should pop in there in a second. I did do that on Bates, right? Yep, on the right interface. Okay. Let's go look at the other router and see what we see. One and 4. Looks like we get to do some troubleshooting. I did turn it off right here. And Bates will see all of them. 1, 3, and 4. I don't think this is the case, but I'm going to check it with you real quick. We applied the no split horizon on the sub interface, which is the way I believe it should be, but I'm going to go to the physical interface. Oh, I see why. Let's go back to the sub interface. Okay, so I put no IP split horizon, which is the proper command. But, however, I do believe the default statement here is for RIP. Don't ask me why, but you do have to specify that it's EIGRP that you're going to allow to pass through. And then you got to put the autonomous system number. So now we're good to go. Let's go back to Bond and check that out. So that's the great thing about doing these videos is, yeah, I'm not going to edit out the mistakes. I could redo the video, but it's great when I get stuck, because if it's something that I could mess up on, it means it's something probably someone else could mess up on. And the best way to catch it is to see me do it. So let's look at Bond's routing table now. And 1, 3, and 4. So yeah, we're good to go. Connectivity wise, let's go from Bond and ping 4.4.4, and it's going to fail. And now I happen to know it's going to fail, and I happen to know I need to show you how to fix it. But this would have been kind of difficult to catch if you weren't knowing that the problem existed, or if you weren't setting up this network and you set it up properly from the get-go. The reason why is the way that these multi-point networks work. You have to basically do the frame relay network is using those mapping commands, and it's almost like doing a static route. So even though the EIGRP routing is going, the advertisements are going through Bates, we don't have a route to Corleone, and to do it, and I don't mean an IP route, because we have an IP route, but we don't have a frame relay route. And let's do that now. Let's look at this. I'll start with Bates. Show frame relay map, and you see that through that interface I have one going down to one side and then one going down the other. So 34.3, that's going to Bond. 34.4, that's going to Corleone. Bond, however, we only have one map, and that's going down Delcy 301 up to 192, 168, 134.1, and that belongs to Bates. So what we have to do is add a mapping for the other router as well. So let's go to configure terminal, interface serial 00, and it should be frame relay map, and IP address, and we're going to be sending it to 192.168.134.4. Which DLC are we using? We're using 301 because we're sharing it. We're on a multi-point network. It's not separate. And the last thing it wants to know is, well, it doesn't require this, but we want to put the broadcast keyword in there so that way we send our routing updates as well. So we're done with that side. Let's go do the same on this router. Interface serial 00, frame relay map IP address 192.168.134.3. That's going to use DLC 401 and broadcast. Now let's try our pings again. Ping 192.168.134.3. And working. So we're good to go now. That was something you have to know whenever you're working with frame relay. It's always really good to look at that show frame relay map command and give that a good look over. As a matter of fact, that CCNA test I took today, this was a very important piece of one of the little testlets I had. You had to be able to use this. So good to know. So that's all set and done. Now we can move on to the next task. Configure EIGRP Atomic System 1 on both of the fast Ethernet links across BATE and oHara. So these two links here, we want to add those to our routing now. Let's go ahead and go to BATEs first. So again, I'll do a show IP interface brief, and I'll do a configure terminal router EIGRP1 network 192.168.12.1. All right, that's BATEs. Let's go ahead to oHara. Now we haven't done any configuration on this one yet. So what that means is I have not added the loopback interface into the routing. So I want to go ahead and also do that. So we'll do a network and 222. Okay. So EIGRP is configured on both of those. Let's look at the routing table. And I should be able to see everything we've passed through so far. So 1, 2, 3, and 4. So everything is nice and inclusive. Now it wants us to change the bandwidth on fast Ethernet 1/0 so that only fast Ethernet 0/0 is used for a successor. Let's scroll up here. Let's look at the, we're on oHara. We're going to BATEs, which is the 1111. You'll see that we're using two routes. We're doing load balancing across these Ethernet channels. And the reason is because they have the same metric. And the way to, let me explain the routes real quick. EIGRP, the actual route that you're using in your routing table is called the successor. And if you have another really good route that is not equal cost, it can go into your topology table as a feasible successor. So there's some rules behind it. I won't go into all the details and make this video way too long. But just know that right now they're equal cost, so they're both in the routing table. So what I want to do is make the metric on one of these larger so that it falls off of the routing table and ends up in the topology table so that we don't do any load balancing. So it wants us to work with fast Ethernet 1/0. So interface fast 1/0. And it wants us to use the bandwidth. So bandwidth. And I want to make this slower. So I'll put 10 in there. And now let's look in here again. Has not gone through yet. Let's try it again. Yep. So now going over to BATEs, we're only using that one route. We're not doing load balancing anymore. Let me find a good way to show you that. Let's do a show IP EIGRP interfaces. So actually I want to do a show IP protocol. Here's our weights, hop count, variance. Okay, what I'm looking for actually is going to be, I'll just do a do show IP interface. I want to show you the default bandwidth. That way you know what we changed it to and what it was before we changed it. That's what I'm looking for. Show IP interface fast 00. It's in one of these commands. Show IP, actually show interface fast 0/0. We want to look at the physical interface, not the IP interface. So there we go. The bandwidth on the interface fast 00 is at 10, it looks like 1000 kilobits per second. Now let's look at the one we just changed, show interface fast 1/0. And now the bandwidth on here is only 10. So much slower. The reason I went through all that trouble though is just to show you that when I put in 10, it wasn't just some random number. I wanted to know what we were changing. This was the default for that line, and anything lower than that number would have caused the equal load balancing to become broken and then put this off of the routing table. So that's what we did with that. So that's all done. So the next thing it wants us to do is configure EIGRP on Dobbs and Corleone, these two routers here. One thing we need to do real quick, we need to do a full routing across all these routers. The interface for oHara going down to Dobbs has not been advertised yet, and that's serial 2/0. So let's do a configure terminal router EIGRP1 network and 192.168.25.2. And just in case I haven't put no auto. So we now have all of the interfaces on oHara done. Let's move to Dobbs. And we have 3 interfaces here. This should give us an adjacency with oHara as soon as we kick this on. And it did. Next is going down to Corleone and our loopback. Okay, so that one's completely configured. Let's go down to our last router. And 3 interfaces again. We already have serial 00 from earlier, one of our first steps, so we need to do serial 0/1. And this is going to give us a new adjacency and also our loopback interface, which actually we already have that in there from the very first step. So, and I'll even verify that. We'll just look at the running configuration and go down to our EIGRP section. So yep, all three networks, and we have no auto summary. So we have full connectivity across the board. The next step is asking us to disable auto summary. We already did that as we went, and then it's saying we should have full connectivity. I don't know how I just did that. Okay, we have full connectivity for all the networks. So from the router we're on, we'll go ahead and try that. We'll do a ping on everybody's loopback interface. Ping 1111, good. Ping 2222, good. Ping 3333, good. Ping 4444, good. Ping 5555. All right, full reachability, so we're good on that. Next, it wants us to create a summary on interface serial 0/0 of Dobbs so that it advertises 5.500/16 with an administrative distance of 85. So from Dobbs onto the interface going up to oHara, which is serial 00. Back to that OSPF versus EIGRP. This is one of the benefits of EIGRP. You can do summarization on any interface of any router other than the OSPF alternative, which is going to be only on your border routers that separate your OSPF areas can you do summarization. So we're going to go ahead and take advantage of that. We're going to go into interface serial 0/0 and we're going to do a IP summary address EIGRP autonomous system 1. What's the IP address we want to advertise? We're going to do 5.5.0.0 and the subnet mask with /16 is 255.255.0.0, and the administrative distance we want to use 85, and that's it. We can hit enter. Now let's go up to oHara and look at the routing table. And looking for the loopback of Corleone, which is 4444. Let's go ahead and update this one more time. oHara, I'm sorry, I'm looking for Dobbs 5555. There we go. So you see that we have two routes now. We have the original route, the more specific route, and that says it's coming in on the fast Ethernet link, and that's coming from oHara over to Bates through the frame relay network through here and out of serial interface 0/1. We're still advertising the specific route, and since we have redundancy with connections on both sides, it's getting the more specific route still, and then here's the summary address, which is getting through the serial interface directly connected. So that means if you're going to use summarization for any good production settings, you want to make sure that you have it on all your interfaces. Otherwise, it's not going to be used because you'll still have the more specific route in your routing table. So just a little tidbit of information, but we did complete the labs requirement, and we had the administrative distance set to 85. You'll see that it still has 90 here, and that's because administrative distance is a local variable, and it doesn't actually advertise a different administrative distance to the other routers. So only on Dobbs itself is the administrative distance going to be lower. Here we go, changing the EIGRP K value so that only delay is used as a metric. Oh, this is sketchy stuff. I would never do this on a production environment, but we're in a lab and that's what it wants us to do. I even pulled out a little cheat sheet because I don't ever memorize these things. Our K values, K1 is bandwidth, K2 is load, K3 is delay, K4 is reliability, and it says here that K5 is MTU, but I'm actually pretty sure that this is a myth, and the K5 actually changes the way the metrics are configured, or like how they're calculated. It's not MTU, unless I'm mistaken. So just know that for our lab, K3, the delay, is the only one that we want to leave on. The rest of them, we're going to turn off. So the way we do that, we're just going to go to configure router. We're already in there on this router. Metric, weights, and it says TOS, we're using 0. K1, we're leaving off. K2, we're leaving off. K3, we're going to put on. K4, we're turning off. K5, we're turning off. Hit enter. So this is going to break all of our adjacencies, because if our K values do not match, we do not get neighbor relationships. So we're going to have to go in here and do this for every router real quick. Router EIGRP 1, and then we'll paste that in. Configure terminal, router EIGRP 1, paste that in. Router EIGRP 1, and lastly Dobbs. As you can see how the logging synchronous is really coming in handy right now, because all of these messages flooding us. If we didn't have this turned on, it'd be very hard to see what we're typing. So everything went down and now everything has come back up. We can look at our routing table to verify all of our routes came back in. 1, 2, 4, 5. Looks like we don't have 3 on here. Bond. Let's see if Bond came back in. There he is. Okay, so everything came back in. So that's already done. Now we can move on to the next. Ensure that router Bates can use the frame relay network as a feasible successor to 444. So from Bates, we're going to go to Corleone, and let's go look at Bates real quick. We're on there. Show routing table. So to go to 4444, it's right now, at this point in time, going through serial interface and going directly to it. That's the best path. So what the lab wants us to do is to make this route the feasible successor, which means the backup route, and therefore it wants us to use the fast Ethernet link as the successor route, or the route that's actually in the routing table. Now, just prior, we changed delay to be the only metric in the calculation for the best route. So that means we need to change our delay values to make that happen so that we can edit the metric. So 4444 currently has a metric of 640,000 going through the serial interface. Do we want to either make this less desirable by increasing the delay, or do we want to go this way and decrease the delay to make that more desirable? I think it'd be easier to make this less desirable, so I can just keep increasing it until something isn't right. So let's go ahead and let's do a show interface serial 0 / interface serial 2 / 0.1. Let's see here. Our delay is currently 20,000, so that we need to increase it above 20,000 to make this less desirable. So let's do a configure terminal interface serial 2 / 0.1 delay. Let's try 25,000. And this is just trial and error. So now we're just going to keep doing a show IP route and repeating until we see that 4.4.4 is not using the serial interface anymore, but instead using the fast Ethernet. And I'm just going to check it one more time in case it just took its time. Oh, look at that. That's all it took. We're now using the fast Ethernet interfaces to get there because the delay is higher on this link. So it's going this way instead. Let's take a look at that topology table and see if we have the other link, the serial link, as a feasible successor. So a show IP EIGRP topology. And look at this. 2 successors, the feasible distance, and we see here's our fast Ethernet links, and here's our serial link. So that means that worked out perfectly. We have this as a backup route. If these interfaces were shut down or disconnected, it would automatically fail over to the serial. All right, so that's done. I'm doing that again on accident. Next is make sure you see the feasible successor route not only in the topology table but also the routing table. So now we got to get this guy out of the topology table and onto the routing table. Remember when we were talking? What? Hold on, phone's ringing. Very loud. Okay. Let's see. Let's not let that set me off here. We're looking at the routing table. Earlier I was mentioning that we have equal cost load balancing. So this is automatic with a default setting. However, you can have unequal cost load balancing by introducing a new command called variance. And what that does is it takes the metric, and instead of having to have an equal metric, you can multiply it by the variance, and then if it falls within that range, it's added to the routing table. Let's make that easier to see by actually doing it. So configure terminal router EIGRP 1 variance, and it goes from 1 to 128. So say I do 100 for the variance. That's a very large variance. That means that our metric can be 100 times smaller or 100 times larger, and then if it matches, they'll be added to the routing table. So let's look at show IP route and see if 4.4.4. There you go. So serial interface and fast Ethernet are all in the routing table now. Here's the metric for the serial interface. Here's the metric for the fast Ethernet interface. You can see that that's about 6 times bigger, but I put in a variance of 100, so it could have been within 100 times bigger, and it would have showed up on here. Actually, hold on, let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 2, 3, 4, 5. Yeah, okay. Just wanted to make sure I wasn't missing a digit. So yeah, about 6 times bigger. So that's completed. That was easy enough. And the last thing it wants us to do for this lab is going to be authentication between Dobbs and Corleone. Right here, these two routers. We're going to do keychain MD5 authentication. So let's go ahead and start with the bottom router. From global configuration, we need to create a keychain. So keychain. The name of the keychain is going to be vault. And then we're going to use the key, and you got to put the number. The key numbers have to match between the two sides. So key number 1, key string, and then the actual password itself is labs. And that keychain is configured. Let's go into the interface serial 01. So IP authentication, we're going to do keychain and the name of EIGRP, autonomous system, and the name of that keychain is vault. Now also we want to do IP authentication mode EIGRP autonomous system 1 MD5. MD5 is much better than plain text. So there we go. That's going to break the communication, and the adjacency goes down until we do the same thing on Dobbs. So interface serial 0/1. Actually, sorry, let's back out. We need to make our keychain, so key chain, and it's called vault. Key number 1, key string, labs. IP authentication, keychain, EIGRP, autonomous system 1, vault, and IP authentication, mode, EIGRP, autonomous system 1, MD5. And that should bring us back up. And there we go, came back up. That is everything for this lab. Let's see, we have a 40-minute video that went a little bit long due to the stumbles along the way. But I'm happy that the stumbles came in, because that means you got to learn a little bit extra, and I got to learn a little bit extra. I hope you guys enjoyed this video and found it educational and entertaining. And if you'd like to see more of these videos, be sure to give it a thumbs up and post some comments down below. If you have questions, definitely ask them of me, and I'll be sure to read those comments and try to answer those questions. Other than that, I just want to remind you, this is Vicious, and I'll see you guys next time.